Everyone, yeah, I think now it is audible. So I welcome you all to the YouTube platform of IMS Gate Academy. Myself Prateek Mishra, and we are discussing about environmental engineering. We are revising this subject through numericals. Yesterday in our first session, we have discussed the topic of water demand, population forecasting, sources of water, and then we were discussing about the water quality parameters, in which we have discussed about the chemical water quality parameter and the physical water quality parameter. And at the end of the session, I have also told you one trick, how to get or how to calculate the content of any substance present in the organic matter. I hope you have enjoyed yesterday's session. Today, more exciting concepts will be coming up. We will be dealing with all these concepts again through numericals. So my best advice is just stay till the end of the video, and I'll make sure that you revise this subject very easily. So before starting this session, my dear students, I have to make few announcements. In order to get the update for all the technical exams and also for the PSU notification, you can get those information in our Telegram group. In our Telegram group, we also post regular quizzes so that our students stay in contact with the technical subject and their preparation is oriented properly. If you want to enjoy the daily quizzes, if you want to have an update about our YouTube series, you can join our Telegram group. The link is provided in the description box and it is even mentioned here, right? The next is, we at IMS Gate Academy, my dear students, conduct different types of classroom program. We provide you with online program, offline program, hybrid program, where the student enjoys the fusion of both online and offline teaching. And then we provide you with the self-learning programs. In all these programs, we provide you with around 800 hours of live teaching. This 800 hours of live teaching includes the interaction and the doubt solving as well. So if you are attending any lecture, if you feel asking any doubt, so you can have a live interaction with our mentors. Next, we provide you with 30 plus theory and exercise book. Especially, my dear students, if I talk about my exercise book, our exercise book, the questions are placed for different subjects, and for every subject we have classified the questions into different chapters. And even for every chapter, our questions are well placed in level 1, level 2 and level 3 category, so that even you can have the proper analysis what is your level of preparation. Then we provide you with 12 one-to-one mentoring sessions, my dear students. Again, the MSP of IMS Gate Academy, the only institute which provide one-to-one session to our students, right? Gate is an hectic journey of like 8 to 9 months, and usually student gets demotivated after halfway through. So there the come of these My Plan sessions. Our My Plan sessions orient our students towards their proper path and also help them to revise the content very efficiently. Then, my dear students, we provide you with 130 plus chapter test, subject test, advanced subject test, multiple subject test and full length mock test. Total number is 130 along with the video solution. So these are the key features we provide you at IMS Gate Academy. If you want to speak to a counselor, the number is mentioned here. You will get Rahman sir and you can have a healthy conversation with him regarding our IMS features and what all things we provide. If you want to speak to our mentors, again you can just contact this number and ask Rahman sir to contact you with any of our mentors, right? Chalo. So these are some of the announcements before we should start the session. I should again remind you, my dear students, environment is one of the highly weighted subject and you should never miss any question asked from environmental engineering, because the concepts are very easy, questions are very easy. The only thing is you need to understand the question and directly application of formula based question you will get in the examination. Okay, so we will start from where we have left yesterday. We were discussing about the chemical water quality parameters and we were discussing about the numericals for that. So here is again one more numerical. I'll give you 2 minutes of time. Just go through this numerical and try to solve it. Go for it. Go for it, go for it. An expected question for your examination. Just go for it, solve it. Just go for it. Again, a concept based question. Just go for it. Not much time is left. Just do it, do it. It's a very, very easy question. So let's see this. Let's see this. Question says that a 500 ml sample of water has initial pH of 10, 45 ml of 0.02 normal H2SO4 is required to titrate the sample to a pH of 4.5. Now 99% of the student after reading this statement leave the question. The reason is they don't know from where this question is framed. So for every question you need to analyze from where it is framed, right? The question is asking us to calculate the total alkalinity of water in milligram per liter as CaCO3. I will solve this question in front of you and you will realize how easy this question is. Now what is this? 500 sample of water has an initial pH of 10, 45 ml of 0.02 normal H2SO4 is required to titrate the sample to a pH of 4.5. Obviously, in order to find out alkalinity, we do the titration by 0.02 normal H2SO4 and we start the titration with a pH of 10, right? pH of 4.5 is that pH where total alkalinity is removed from the system or total alkalinity is neutralized by this acid. So what is given to you in the question is, you can relate with this curve. On the y-axis, if I draw the pH, on the y-axis, if I have the pH value, and on the x-axis, if I have the volume of acid used, and this plot we usually understand in order to understand the alkalinity, right? We start the titration at a pH of 10, okay, and then we keep on adding the acid. At a pH of 8.2, we got our first color change of phenolphthalein, and then again at a pH of 4.5, we get the second color change, like this. At pH of 4.5, our entire titration is completed and we note down the volume of acid used. So directly you are given with the total volume of acid used to neutralize all the alkalinity. So I'll write like this: at pH of 4.5, all the alkalinity is removed. All the types of alkalinity is removed. All the types of alkalinity is removed from the system. All the types of alkalinity is removed from the system, right? Now, how to calculate this alkalinity? So, first you need to calculate number of gram equivalents of alkalinity. So, alkalinity of the medium is equal to number of gram equivalents of alkalinity, multiplied by the equivalent weight of CaCO3. equivalent weight of CaCO3. This is how you need to calculate the alkalinity. Now, number of gram equivalents of alkalinity is equal to the number of gram equivalents of acid used. Number of gram equivalents of acid used is equal to normality of acid, which is 0.02 into 45 ml. So, 45 into 10 raised to power minus 3. These are the number of gram equivalents of acid. Now, these many number of gram equivalents of acid are used to neutralize alkalinity present in 500 ml of the sample. So, for 1 liter, you need to divide by 500 and you need to multiply by 1000. Okay. So, this is the total number of gram equivalents of alkalinity present in 1 liter of the water sample. Now, you need to multiply with this with the equivalent weight of CaCO3. So, equivalent weight of CaCO3 is molecular weight of CaCO3, which is 100, divided by the valency of CaCO3, which is 2. So, this is how you can calculate the alkalinity and you can report it as CaCO3. Just do the calculation and let me know the answer for this. So, this is 0.02 into 45 multiplied by this will be 0, this will be 1, this is 50, 500, so divide by 10. 0.09 gram per liter as CaCO3. So, alkalinity comes out as 0.09 gram per liter as CaCO3. You need to convert this gram into milligram, so you multiply it by 1000. So, alkalinity comes out as 90 milligram per liter as CaCO3. 90 milligram per liter as CaCO3. So, this is my final answer. This is your total alkalinity, right? So, whenever the questions are framed like this, usually you will get a statement when the entire process will be explained to you in the form of statement like this. So, never miss these questions, right? These are very, very easy questions. Chalo, moving on with this next question. This is your next question. Take 2 minutes of your time and go for it. Just do it. Go for it. It's a very, very easy question. Do it. All these are gate 2 marks question already asked, right? Do it, do it. Let's see this question. The question says that effluent from industry A has a pH of 4.5. The effluent from industry B has double the hydroxyl ion concentration. I'll write like this. This is industry A. This is your industry A. and this is your industry B. pH of the effluent from industry A. So I'll write like this: pH of effluent from industry A is given as 4.5. Okay. Next, the effluent from industry B has double the hydroxyl ion concentration than that from effluent from industry A. Means OH minus ion concentration for industry B is 2 times of OH minus ion concentration for industry A, right? The pH of effluent from industry B will be, you need to find out pH of the effluent from this industry. Now, how to solve this question? First of all, you need to get the value of OH minus ion concentration from industry A. How to get this? So, I know one relation, pH plus POH is 14. pH is 4.5, POH I can calculate is 14. So, from here the value of POH for industry A comes out to be 9.5. POH for industry A, this comes out as 9.5. Okay. Now, this POH for industry A can be written as negative log to the base 10 of OH minus ion concentration, and this is equal to 9.5. From here you can get the value of OH minus ion concentration. Just do this, get me the value. So, this comes out as 3.16 into 10 raised power minus 10. So, OH minus ion concentration for industry A this comes out as 3.16 into 10 raised power minus 10 moles per liter. This is how we report the concentration. This is your concentration for OH minus ion for industry A. From here you can calculate the OH minus ion concentration for industry B. So, OH minus ion concentration for industry B is 2 times of OH minus ion concentration from industry A. So, this is equal to 2 into 3.16 into 10 raised power minus 10 moles per liter. Okay. So, this will be how much? 6.32. This will be 6.32 into 10 raised power minus 10 moles per liter. Now, using this you can calculate the POH for industry B. So, you can calculate POH for industry B. So, POH for industry B is negative log to the base 10 of OH minus ion concentration for industry B, right? You can substitute the value of OH minus ion concentration for industry B from here. So, this will be minus 10 minus log to the base 10 of 6.32 into 10 raised power minus 10 moles per liter. So, this is your POH for industry B. Calculate this. So, log of 6.32 so 10 minus answer will be 9.199. So, this will be 9.199. This is your POH for industry B. Using this you can calculate pH. So, pH for industry B plus POH for industry B is equal to 14. pH I need to calculate. So, pH for industry B is equal to 14 minus POH for industry B, which is 9.199. Do this. This will be 4.7 This will be 7 or 8. Yeah, this will be 4.811. This is your pH, or this will be 4.8 only. This is your pH for industry B. Where if you round this off, this will be 9.2. 14 minus 9.2 will be 4.8. This is how you need to deal with this question, right? This was a GATE previous year question, already asked for 2 marks. Again, a very important category. Last year also we have seen questions from pH. So this becomes a very important category. Okay, I hope you have understood this. Let's move on to the next. Try this. So when we talk about the biological water quality parameter, in biological water quality parameter, we need to find out the number of pathogens present in the water sample. What are pathogens? Pathogens are disease causing microorganisms. But here I would like to bring one thing in your notice. Whenever we are calculating biological water quality parameter, or just by the name of biological water quality parameter, we mean the calculation of pathogens. I need to calculate pathogens present in the water sample. But my dear students, the best part is calculation of this pathogens is a very tedious work and it's a very costly affair. So practically what we do is, we calculate the colonies of coliforms. We calculate the colonies of coliforms, and in coliforms also E. coli. We calculate the colonies of coliforms. Colonies of coliforms or colonies of coliforms, colonies of coliforms are calculated or are measured. So practically we measure the colonies of coliforms, right? And these colonies of coliforms are calibrated with the colonies of pathogens. The colonies of coliforms, the colonies of coliforms, colonies of coliforms, colonies of coliforms are calibrated with the with the colonies of coliforms, with the colonies of pathogens, with the colonies of pathogens. So actually what we need to calculate? We need to calculate pathogens. But what we are calculating? We are calculating coliforms. Coliforms are non-disease causing microorganisms. They will not cause any disease, right? So we calculate the colonies of coliforms because it is very easily calculated, it can be very easily measured. Colonies of coliforms are calibrated with the colonies of pathogens, right? So indirectly we calculate the colonies of pathogens. We have one very beautiful test which is known as most probable number test, MPN test. From there you get one question from here. Just do this, try to do this. I'll give you just 1 minute of time, go for it. Only 1 minute of time, because MPN test does not require much time. Just go for it. MPN test does not require much time. Questions of MPN test are very easy. Let's see this. The question says that a water sample is analyzed for coliform organisms by the multiple tube fermentation test. This multiple tube fermentation test is the another name for MPN test. Multiple tube fermentation test is the another name for MPN test. This is the MPN test that we have conducted. Okay. For the sample dilution set of 0.01, 0.001 and 0.0001, this is the set of dilution that you have prepared, right? The number of positive test result tubes out of 5 each were obtained as 422. So these are number of positive tubes. Number of positive tube means in which we get this popping sound, in which we get the decomposition of the organic matter. The most probable number of coliform organism from the above result obtained using the MPN indexes. So this is your calibration chart given to you. Whenever you are dealing with a question from MPN chart, what you have to do is, first of all, you need to match this combination. The positive test tube combination is 422. Just match with this, right? This is the combination of positive test tube. So this is your combination. Corresponding to this positive combination of 422, the MPN value is 96. Okay, the MPN value is 96. First step is very clear. Whenever you are getting a question from the MPN test, first thing is you need to measure the number of positive tubes, and using this number of positive tubes, you have to match the calibration chart. In calibration chart, this 422 corresponds to 96 of MPN index. I'll write this. So corresponding to the combination of 422, MPN index is 96. But this is not my final answer. Okay, for the final answer, observe carefully. First of all, what is the dilution that you have prepared? Dilutions prepared. What are the dilutions that you have prepared? So these are the dilutions that you have prepared over which the test was conducted. 0.01, 0.001, 0.01, 0.001 and 0.0001. These are your dilutions that you have prepared. Now what are the dilutions for the MPN chart? Dilution for MPN chart. Dilution for MPN chart. Observe this. Dilution for MPN chart is 10 ml, 1 ml and 0.1 ml. So 10 ml, 1 ml and 0.1 ml. These are your dilutions for the MPN chart. So your final MPN index or your final MPN answer is, final MPN index or final MPN answer is, so your final answer is, observe this, you will not find this formula anywhere else. Final answer is, or final MPN index is, final MPN value per 100 ml is, final MPN value per 100 ml is how much? This is equal to the MPN value from the chart is equal to MPN value from the chart, MPN value from the chart. You will not get this anywhere, right? So observe this, MPN value from the chart multiplied by the first dilution, MPN chart, divided by the first dilution of sample prepared, You will never have a confusion in reporting the final answer for the MPN chart. Okay. So what is the MPN value from the chart? It is 96. MPN value from the chart is 96 multiplied by the first dilution of the MPN chart. This is your first dilution of the MPN chart, which is 10 ml, divided by the first dilution of the sample prepared. This is your first dilution of the sample prepared, 0.01. So accordingly you can report this answer. Sir, ये कौन सी class चल रही है? बेटा, this is civil engineering environment class. So this is 96 into 10 divided by 0.01. just find this. So this will be 96 into 1000. So this will be 96,000. This is my final MPN answer. This is my final MPN value per 100 ml. This will going to tell me the MPN value per 100 ml, right? Don't forget this formula. This formula you will not get in any of the textbook. This formula you will not get in any of the textbook, right? So you can have this formula directly in order to report the final MPN value. You will never get confused if you just follow this MPN value for the chart. So whenever you get any question from the MPN chart, right, first thing is you just match the positive combination and take out the value from the MPN chart, right? Right now it is 96, you have taken out. Next, you need to apply this formula. So final MPN value per 100 ml is equal to MPN value from the chart multiplied by the first dilution of the MPN chart divided by the first dilution of the sample prepared. So this is my final answer, 96,000. This is my final answer, okay. So this is how you need to deal with your questions for asked from biological water quality parameters. So this finishes are all the three water quality parameters: physical, chemical and biological water quality parameter. Now my dear students, once you know the quality of water, the next step is to give the treatment to this water. Now why we are giving the treatment? We are giving the treatment to bring all the values or all the parameters within the permissible limit, okay. If any parameter value is above the permissible limit, we will going to treat the water in order to bring down that parameter within the permissible limit. I'll give you one example. For example, you have a water sample. Now this is also a gate question. You can take it as a question as well. If you have a raw water sample, if you have a raw water sample, for which turbidity is for which your turbidity is 3 NTU, okay, pH is 5, suspended solid concentration is say 50 milligram per liter. Suspended solid concentration is 50 milligram per liter. Chloride content is 300 milligram per liter. This is the report I am giving you for a water sample, right? Alkalinity of the water sample is again 300 milligram per liter as CaCO3. Then next, your fluoride content is 3 milligram per liter. Now the question the person is asking, this water is given the treatment for the removal of which parameter? Which parameter should be treated by giving the treatment to this water? Which all parameters require treatment? Which all parameters require treatment? Which all parameters require treatment, right? This type of question you get in examination, and this is also one of the GATE previous year question asked for 2 marks. Data was different. I have framed a question instantaneously for you. So just tell me which all parameters need treatment. So how you will do this? You will compare the value of turbidity with the permissible value of turbidity. If the value of this parameter is less than the permissible limit or the acceptable limit, then this parameter does not need any treatment. But if the value of this parameter is above the permissible limit, then this parameter needs treatment, okay. So in order to find out the water is treated for which all parameters, I have to write down the permissible limit, and then I have to compare whether the value of the parameter is within the permissible limit or it is above the permissible limit. Let's see. So first of all, let me write down the permissible limits. So permissible limits I write like this. For turbidity, permissible limit is 1 NTU. Okay. I'll write all the permissible limit. For pH, the permissible limit is 7 to 8.5. Next. For suspended solids, the permissible limit is 30 milligram per liter. For your chloride content, the permissible limit is 200 milligram per liter. 200 milligram per liter. For your alkalinity, again the permissible limit is 200 milligram per liter as CaCO3. This is again 200 milligram per liter as CaCO3. Next, for fluoride content, the permissible limit is within 1 to 1.5 milligram per liter. 1 to 1.5 milligram per liter. And then you have to compare, right? Just compare. The value of turbidity in your water sample is 3 NTU, but permissible limit is 1 NTU. So we need to treat the water to remove the excess turbidity, and we need to bring down the turbidity of the water sample below 1 NTU. So water needs treatment for turbidity. Second, for pH, the pH is 5. So we need to make the pH between 7 to 8.5. So again the water needs treatment for the pH as well. Then for suspended solid, the value is 50 milligram per liter. We need to bring down to 30 milligram per liter. So again we need to treat this water for the removal of suspended solids as well. Next, we have the chloride content. Right now the value of chloride content in the water sample is 300 milligram per liter, but the permissible limit is 200 milligram per liter. So we need to bring down the chloride content up to 200 milligram per liter. So water needs treatment for chloride content as well. Next, you have the alkalinity. Right now the alkalinity is 300 milligram per liter. The acceptable limit is 200 milligram per liter as CaCO3. So we need to remove this excess alkalinity as well. So we need treatment for alkalinity as well. Next, you have the fluoride content. Right now the fluoride content is 3 milligram per liter, but the permissible limit of fluoride is between 1 to 1.5. So we need to reduce the fluoride content from 3 milligram to liter to below 1.5 milligram per liter. So the water needs treatment for all these parameters. Like this, you can expect a question from your examination, right? Where all these acceptable limits will be used that we have discussed yesterday. So all the values that we have discussed yesterday are important. Like this, you can get a question, right? So one thing is clear right now. Then if we are providing treatment to the raw water, we are providing treatment in order to reduce the value of all the water quality parameter below the acceptable limit. If any water quality parameter has the value above the acceptable limit, then we need to treat this water and bring down the value within the acceptable limit, right? So this is how you can decide on that. Okay, now next is treatment of raw water. Now my dear students, the degree of treatment or the amount of treatment given to the raw water depends on two parameters. The degree of treatment or the amount of treatment given to the raw water, the degree of treatment or the amount of treatment given to the raw water depends on two things. First one is the existing quality of raw water. Depending on the existing quality of raw water. Now what is the existing quality of raw water? The existing quality of raw water is this. These values that we have written in white, all these are the existing quality of the raw water, right? The second thing on which the degree of treatment depends is the desired quality of treated water. The desired quality of treated water. Desired quality of treated water. Desired quality of treated water, right? Now what are the desired quality of treated water? Desired quality of treated water are nothing but like these values, the permissible limits. So our desired quality of the treated water should have the values of all the parameter within the permissible limits, right? So the degree of treatment given to the raw water depends on two things. First one is the existing quality of the raw water. Second one is the desired quality of the treated water. Okay, now next, how we give the treatment? Our treatment starts with the first mechanism of screening. My dear students, screening is responsible for removing coarse suspended solids from your raw water. Second, you have aeration. Now aeration is a process of the addition of oxygen into your water. This addition of oxygen removes all the dissolved organic matter. It removes your color causing compounds. It removes taste and odor. The only thing is aeration adds some acidity to water. Next you have coagulation and flocculation. This is the mechanism of removing or not removing. This is the mechanism of agglomerating fine suspended solids present in your raw water. Next you have the sedimentation. Sedimentation is the removal of suspended solids from your raw water. Next you have softening. Between here you have filtration as well. You have the mechanism of filtration. You have the mechanism of filtration. So filtration basically removes the leftover suspended solids and the fine suspended solids which are present in your water sample. Next you have softening. Softening is a process of removal of hardness from the water. And lastly you have disinfection, and disinfection, as you already know, disinfection is a mechanism of removing only disease causing microorganisms from your water sample. So this is how we go with the treatment. If I start this treatment one by one, so first of all you have screening. My dear students, screening removes the coarse suspended solids from your water sample. Very important. Every process what it is removing is very important, right? Because you should have clear idea about what is removed using which mechanism. So first of all you have the screening. Screening removes coarse suspended solids. Screens are placed in the inclined mechanism in order to increase the area of screening. If you place the screening in the inclined form, then the area or the efficiency of screening also increases. Next, coarse screens are used for the treatment of plants. The head loss through the screen is equal to HL is equals to K upon 2G. This is a constant, V square minus U square, where V is the velocity through the screen and U is the velocity of approach. So you can just imagine like this. If this is your water sample, if this is your water flowing to the screen like this, right? And this is how your screens are placed. This is how your screens are placed. So this is known as velocity of approach U, and velocity through the screen, this is known as V. Okay. So U is the velocity of approach and V is the velocity through the screen. Over the period of time, the value of V will going to increase because the pore size of the screen keeps on reducing as more and more suspended solids will going to clog the voids. So value of V over the period of time will increase, but the value of U is constant. So over the period of time, V will going to increase, but U will be constant. Right? So from this what I can infer is, if V is increasing and U is constant, over the period of time the value of head loss also increases through the screen. Okay, so this is about screen. Next you have this question. Just do this. Try this question. You have this question, just try this. Have your 1 minute of time. Go for this. Please comment your options, your answers in the comment box. Please comment your answers in the comment box. Keep doing it. Please comment your answers in the comment box. So let's see this. The question is saying that which of the following statements are correct? Okay, you need to identify the correct statement. First of all, fine screens can remove finer size of suspended solids, hence used for the treatment of community water. My dear students, fine screens are never used for the treatment of community water. Reason is, no, it doesn't matter whether the fine screens can remove finer particles or not. The fine screens have very small size of pore opening. Okay, the pore opening size is very less, due to which fine screen gets clogged very frequently, and this frequent clogging of the fine screens adds the operation cost for the treatment of raw water. That's why, due to this frequent cleaning required for fine screens, the fine screens are not used for the treatment of community water. So this statement is absolutely incorrect. Next, coarse screens are known as bar screens with a bar spacing of 20 to 100 mm. So this is absolutely correct. Coarse screens are also known as bar screens and having the spacing between the bars between 20 to 100 mm. Next, screens are always placed in the inclined form to the flowing water, which helps in the effective cleaning of the screens. If you place the screens inclined, right, it helps in the effective cleaning, but the main reason of keeping these screens in the inclined form is to increase the area of contact between screen and water. If area of contact between screen and water increases, then the efficiency of screening also increases. So this statement is partially correct or partially incorrect, what I should say. So I will right now mark it as incorrect, okay, because the reason why we keep the screens in the inclined form is because to increase the efficiency of screening. Next, head loss through the screen increases over the period of time. This is absolutely correct. I have just now explained you. Velocity through the screen keeps on increasing over the period of time due to the clogging of voids, which leads to the increase in the head loss. So for this question, your statement B and statement D are your correct options. Okay, moving on with this. Next process is known as aeration. Aeration is a mechanism by which we bring the water in intimate contact with the air. We bring the water in intimate contact with the air, right? We bring the water in intimate contact with the air so that the exchange of oxygen from air to water can take place. So that the exchange of oxygen from air to water can take place, and this exchange of oxygen increases the dissolved oxygen content of the water. And if dissolved oxygen content of the water is increased, the decomposition of the organic matter will take place, removal or the oxidation of the color causing compound will take place, oxidation of the taste and odor causing compound will take place. So aeration removes dissolved organic matter, it removes dissolved gases, it removes taste, odor and color causing compounds, and all this removal is due to the oxidation taking place due to the addition of this oxygen, right? Next, it increases the acidity of water. We have 4 different methods of doing the aeration. First one is your spray nozzle method, second is your tray tower method, third one is your cascade aerator, and fourth one is your diffused aerator, right? So spray nozzle method and diffused aerator require additional cost for the development of pressure. That's why these 2 mechanisms are not used for treating the community water. These 2 mechanisms can be used for the personal use or for industrial use. But tray tower method gives the highest efficiency of aeration, but due to the huge size of tray required to treat community water, we do not use tray tower method for treating the community water. The size of the tray comes out in kilometer and it is not practically possible to provide that much size of the tray. So tray tower method is one of the most efficient method but not used to treat the community water. But cascade aerator, these cascade aerator, first of all my dear students, are the least efficient method, but due to zero operational cost, zero maintenance cost, not operational cost, zero maintenance cost, these cascade aerator is one of the most rapidly or frequently used method of aeration. So in treating the raw water in the water treatment plant, we go with the cascade aerator, right? So this is about aeration. Just go for this question. Take 1 minute of your time and keep commenting your answer in the comment box. Live chat is ongoing. Keep commenting your answer. Take 1 minute of time. Go for this question. Go for this question. Try to solve it. Keep commenting your answer in the comment box. So let's see this question. The question says that which of the following statement is incorrect? So here you need to identify the incorrect statement, okay? Statement 1 says that aeration removes dissolved solids from the water. This is absolutely correct. It removes dissolved solids. Dissolved organic solids we have seen. It carries out the oxidation of dissolved solids present in the water. Next, aeration removes the suspended solids from the water. Now, my dear student, this is absolutely incorrect. Aeration does not remove suspended solids from the water. Next, aeration removes the color causing compounds like iron and manganese but decreases the acidity of water. Up till here the statement is absolutely correct. It removes iron and manganese but it not decreases but it increases the acidity of water. It increases the acidity of water. So this statement is also incorrect. Then you have spray nozzle method is the most efficient method of aeration. My dear students, tray tower method is the most efficient method. So this statement is also incorrect. So instead of spray nozzle, tray tower method is the most efficient method of aeration, right? So for this question, statement B, C and D are incorrect. Statement B, C and D are your incorrect statement, right? Chalo, moving on with this. Next. So once you are done with screening and aeration, the next mechanism comes as sedimentation. Sedimentation is the process of removal of fine suspended solids. So sedimentation removes fine suspended solids. It removes fine suspended solids. Or I would like this. It removes suspended solids. It removes suspended solids from your raw water, right? Next, sedimentation, the mechanism of sedimentation depends on one parameter which is known as specific gravity. Okay, so first you need to think on this. Sedimentation means settling of solids. We allow the water to settle for some time, and during this settling time, these solids which are present in the water will going to settle under its own weight. Now the only parameter responsible for the settling of the solids is termed as your specific gravity. So the entire mechanism of sedimentation depends on one parameter which is known as specific gravity, right? What is specific gravity? You can understand specific gravity like this. It is the relative weight of the solid with respect to water, right? With respect to water, what is the relative weight of solid? If the relative weight of solid with respect to water is more, so obviously the solid is heavier than water and solid will going to easily settle down, right? But if the relative weight of solid is less than water, like the example is feather, the relative weight of feather is less than that of water, so feather floats on the surface of water. Feather does not settles down. So specific gravity is defined as the weight of solid of given volume divided by the weight of standard fluid. The standard fluid is nothing but water. This standard fluid is nothing but water. So specific gravity is defined as density of solid divided by the density of water, or it is also defined as unit weight of solid divided by the unit weight of water, right? Now when this solids are settling, they are governed by the different factor. The settling of these solids is governed by different factors. The first factor is velocity of flow or turbulence. If velocity of flow or turbulence is more, obviously the settling of the solids will be less. Okay. Second, the viscosity of the fluid. If the fluid is thicker, right, you can take an example of water in one jar and honey in another jar. Honey is thicker than water. So if you drop a solid in both the jar, then the solid which is dropped in water will settle easily, but the solid which is dropped in honey will feel more resistance in settling. So if viscosity of the fluid is more, the settling of the solid will be less in that fluid. Last one is the size of particle. For comparing the size of particle, you should make sure that all these particles are of or having same specific gravity. If the specific gravity of all these solids are same, then more the size of the particle, more will be the settling of solids. So these are the three parameters that affects the settling of solids. Now, when the solid is dropped inside the water, it will going to settle with a constant velocity, and that is known as the settling velocity. This settling velocity is defined using the Stokes law, and this settling velocity comes out as Vs is equals to under root 4 gd into g minus 1 by cd, where g is acceleration due to gravity, d is the size of the particle, this capital G is the specific gravity, and this cd should be written like this. This cd is coefficient of drag. This is your cd, which is your coefficient of drag, right? And this is defined using Stokes law. Anywhere it is written? No. So this is your Stokes law. It is defined using Stokes law. It is defined using Stokes law. So this is the general expression for settling velocity. It is applicable for all type of flow, whether the flow is laminar, transition, turbulent, any type of flow. You can use this expression for calculating the settling velocity. But if your flow is laminar, that is your Reynolds number is less than 1 and the size of the particle is less than 0.1, then for this case we have one more formula for calculating the settling velocity, that is equals to 1 upon 18 gamma w d square into g minus 1 by mu. Vs is equals to 1 upon 18 gamma w d square into g minus 1 by mu. Very important formula, very important formula. Vs is equals to 1 upon 18 gamma w d square upon g minus 1 upon mu, g minus 1 into mu, right? So first of all, Vs is your settling velocity. Now observe this, I'll write here. For laminar flow condition, for laminar flow condition, settling velocity Vs is equal to 1 upon 18 gamma w d square into g minus 1 by mu, right? Mu is the coefficient of dynamic viscosity. Everything I am writing because this formula is very important. You can expect a question from this formula. Mu is the coefficient of dynamic viscosity. Mu is the coefficient of dynamic viscosity. Sometimes instead of dynamic viscosity, they give you kinematic viscosity. They give you nu, coefficient of kinetic or kinematic viscosity. Coefficient of kinematic viscosity, right? Now this nu is equal to mu by rho w. This you should keep a check. You should not leave any question just because you are not given the value of dynamic viscosity. Sir, the MPN equation you give in the applicable for any multiple or any the same multiple of MPN chart and dilution value. My dear Nikhil, that equation is applicable everywhere. Doesn't matter what is the dilution of MPN chart or what is the dilution that you have taken to means perform the test. That is one of the most general equation. So actually what happens is ki in the book you are explained in terms of dilution, and understanding and reporting the answer in terms of dilution is very confusing. So in order to remove that confusion, you can use that equation directly. You will never commit a mistake. First you need to, what you have to do? You have to match the positive tubes, then you have to take the MPN value. And the final answer that you have to report is that MPN value multiplied by that factor. First dilution of the MPN chart divided by the first dilution of the samples taken, right? Okay, so I was talking about this settling velocity Vs is equals to 1 upon 18 gamma w d square into g minus 1 by nu. So if instead of mu is given to you, then this is the formula that you should use, right? If you are using this formula, the settling velocity formula is also modified. So Vs is equal to 1 upon 18. This gamma w can be written as rho w into g into d square into g minus 1 by mu, right? Now this mu by rho w, this can be replaced as nu. So I will write down Vs is equal to 1 upon 18 g into d square into g minus 1 divided by nu. So this is your another formula for calculating the settling velocity. So it doesn't matter whether which viscosity is given to you, right? Any viscosity you can calculate the settling velocity. Okay. Now next is every settling tank. Okay, every settling tank is first of all designed for the removal of concerned size of the particle. The settling velocity of the concerned size of particle for the removal of which the settling tank is designed is termed as surface overflow rate. So here I have written surface overflow rate, right? What is surface overflow rate? It is the settling velocity of the concerned size of particle for which your settling tank is designed. The plan area is equals to design discharge divided by surface overflow rate, and volume is equal to design discharge multiplied by the detention time. Again, these two are very important expression. Surface overflow rate is the settling velocity of the concerned size of particle for which the tank has been designed. What is the concerned size of particle? It is that size of particle for which the settling tank has been designed, right? Chalo, let's move ahead. Okay. So for different types of sedimentation basin, we have two types of sedimentation tanks. First of all, we have fill and draw type sedimentation tank, and then we have the continuous flow type sedimentation tank. So fill and draw type sedimentation tanks are simple. You just make a tank, fill the water for 24 hours, allow the water to settle for 24 hours. In this 24 hours, whatever solids are present, they will going to settle, and then you draw this water out, right? So this is again not used for treating the community water. This can be used for personal use. Next, for continuous flow type sedimentation tank, we have two types of tank, horizontal flow type tank and we have the vertical flow type tank. We know this, horizontal flow type tank also removes some amount of particles which are having the size less than the concerned size. Okay. So horizontal flow type tank, if d naught is the concerned size of the particle, then the particles of size greater than d naught, these size of particles are 100% removed. Particles of size greater than the concerned size are 100% removed in the horizontal flow type tank. But the particles of size less than d naught, these size of particles, smaller size of particle, they are also partially removed. They are also partially removed, right? And this partial removal can be calculated as, this percentage removal can be calculated as settling velocity of the smaller size of particle Vs1 divided by Vs. Vs is the settling velocity of the concerned size of particle, which is d naught. So Vs1 by Vs into 100. Similarly, it is also calculated if the flow is laminar, it is d1, which is the size of smaller size of particle divided by d naught square, d1 square by d naught square into 100. So partial removal or the percentage removal for smaller size of particle is equal to Vs1 by Vs into 100. For laminar flow condition, that percentage removal can also be calculated as d1 square by d naught square into 100. Okay. The efficiency of sedimentation is equal to percentage concentration multiplied by the percentage removal. Okay. If I talk about the vertical flow type sedimentation tank, vertical flow type sedimentation tanks are only capable of removing of particles which are having size more than the concerned size. This vertical flow type tank cannot remove the particles of size having size smaller than the concerned size. So there is no concept of partial removal for vertical flow type tank. It can only remove particles of size equal to or greater than the concerned size. So from here only you can tell me which tank can remove more particle. So horizontal flow type tank can remove more particle because there is a provision of partial removal in it. But vertical flow type tank cannot remove it. Okay. So the efficiency of vertical flow type tank is always less than the efficiency of your horizontal flow type tank. Then there is one parameter which is known as displacement efficiency, which is equal to the average flow through period divided by your theoretical detention time. So more the displacement efficiency, less will be your short circuiting. What is short circuiting? Short circuiting means if TD is the time allowed for the settling of water, if TD is the time that we have practically calculated for settling of water, if TD is the time that we have calculated theoretically for the settling of water, but practically the time available with the water to settle is known as average flow through time. Theoretically we have decided that TD is the time available for settling, but practically the time available for settling is T average. Okay. So due to this value of T average, some suspended solids which were supposed to settle, they flow out of the sedimentation basin, and that is known as short circuiting. So this displacement efficiency tells us about how much short circuiting is happening. More the value of displacement efficiency means the value of T average is approximately coming close to the value of TD. More the value of displacement efficiency means the value of T average is coming close to TD, means less will be your short circuiting. Okay. So this is your very important parameter of displacement efficiency. So more the displacement efficiency, less will be your short circuiting, right? Just do this. This is one of the question from the sedimentation tank. Just go for it. Take 2 minutes of time, do this. Again a GATE previous year question. Please comment your answer in the comment box. Keep commenting your answer in the comment box. Keep commenting your answer in the comment box. Just do it. Keep commenting your answer in the comment box. Do it, do it. So let's see this. Question is saying that calculate the ratio of minimum size of particles that are completely removed from two identical sedimentation tanks with surface flow rates of 25 meter cube per meter square per day and 16 meter cube per meter square per day, right? So you are given with very good, 5/4, very good, absolutely correct, Nikhil. So you are given with the two sedimentation tanks. This is my first sedimentation tank and this is my second sedimentation tank. For the first sedimentation tank, the surface overflow rate is for the first tank is 25 meter cube per meter square per day, right? For second tank, your surface overflow rate is given as 16 meter cube per meter square per day. This is the surface overflow rate given to you. Now, surface overflow rate is nothing but the settling velocity of the concerned size of the particle. So, this is your settling velocity of the concerned size of the particle. So, this is settling velocity of the concerned size of particle for tank 1, and this is the settling velocity for concerned size of particle for tank 2, right? I know this settling velocity Vs is directly proportional to the size of the particle, the square of size of the particle. Okay, so what I will do is, I will take this ratio of Vs1 by Vs2 is equal to d1 square by d2 square. So, this is equal to 25 by 16. From here you can calculate the ratio of d1 and d2. So, d1 by d2 comes out as 5 by 4, and this will come out as 1.25. This will come out as 1.25. This is my final answer. Very good, Nikhil. Correct answer. So, this is the ratio of minimum size of the particle that are completely removed, and minimum size of the particle is nothing but the size of the concerned size for which these two tanks are designed. Okay, chalo, moving on with this. Try next question. Try this one. I'll again give you 2 minutes of time. Go for this. Go for this question. Do this question, comment your answer in the comment box. Comment your answer in the comment box. Keep commenting. Keep commenting, keep commenting. So let's see this question. The question says that surface overflow rate for a primary settling tank which is having discrete particle settling is 18,000 liters per meter cube per day. So first of all, I'll write down Vs is given as 18,000 liters per meter cube per meter square per day. Liter per meter square per day. So first of all, convert this liter into meter cube. So this will be 18 meter cube per meter per day. Okay, next, the kinematic viscosity of water in the tank is 1.01 into 10 raised power minus 2 centimeter square per second. So nu is given to you as 1.01 into 10 raised power minus 2 centimeter square. So convert this into meter square. So 10 raised power minus 4 meter square per second, right? So this will be 1.01 into 10 raised power minus 6. This is 1.01 into 10 raised power minus 6 meter square per second. Okay. Next, specific gravity is 2.65. Acceleration due to gravity is 9.81. the minimum diameter in micrometer rounded off to 2 decimal places of the particle that will be removed with 80% efficiency in the tank is. So this time percentage removal is given to you as 80%. Percentage removal is given to you as 80%, right? Now what we can do is, let me assume that the particle of size, say the size of the particle is d1. The size of the particle which is removed with 80% efficiency is d1, and for this size of particle the settling velocity is vs1. Okay, the particle which is removed with 80% efficiency, the size is d1 and the settling velocity is vs1. Now I will use this expression of percentage removal. So percentage removal, I'll write in the next slide. Percentage removal is equal to Vs1 divided by Vs into 100. Okay, Vs1 I need to calculate. Vs is given to us as 18 meter cube per meter square per day, right? Multiplied by 100 is equal to 80. From here you can get the value of Vs1. Just calculate this. Get the value of Vs1. So this will be 18 into 0.8. So this will be 14.44. Vs1 is 14.44 meter cube per meter square per day, right? Units are very important. In just a small while you know the importance of the unit. How a small unit can change your whole answer, you will just realize in just a small fraction of time. Observe this. Now I got the value of Vs1. Using this Vs1, I can calculate the size of the particle d1. So how to get this? So Vs1 is equal to 1 upon 18 g into d square into g minus 1 divided by nu. This is the expression for calculating the settling velocity when your dynamic viscosity is given to us. So Vs1, so here d1 will come. So Vs1 is equals to 1 upon 18 g into d1 square into g minus 1 by nu, right? Substitute all the values. Substitute the value of Vs1. Vs1 is given to you as, you have calculated as 14.4. This is 14.4. Now this is meter cube per meter square per day. So you need to convert this into seconds. So how much it will be? This will be 24 into 3600. This is your seconds, right? Next, this is 1 upon 18. G is 9.81. D1 square. G, capital G is 2.65 minus 1. And you have also calculated the value of nu. So this is 1.01 into 10 raised to power minus 6, and this is meter square per second. Okay. Now this is also in meter per second. This is also in meter square per second, right? So from here the answer that you will get will come out in meters. The answer that you will get for D1 will come out in meter. You need to convert that into micrometer. So first of all, tell me the answer in meters. Just do the calculation for this. Just do the calculation for this. So how much it will be? So this will be 1.65. 1.65 into 9.81. Okay, into 24 into 3600. Okay. So into 2, 3, 4, 5, 6. Okay. 1 divided by answer into 14.4 into 18 into 1.01. Okay, so this is your answer. So root of answer is 1.368 into 10 raised to power minus 5. So D1 comes out as 1.368 into 10 raised to power minus 0.5, right? If you take this also, so it will come out as 0.1368, 0.1368 into 10 raised power minus 6 micrometer. Sorry, this is meters. This is meters, right? This is meters. Now this 10 raised power minus 6 and meter, this will be micrometer. So your size of the particle D1 will be 0.138, 0.1368 micrometer. This is the size of the particle. This is the size of the particle that will be removed with the efficiency of 100%, right? Sorry, 80%. This is the size of particle that will be removed with the efficiency of 80%. Obviously, this size of particle is lesser than the size of concerned size. Chalo, moving on with this, try this question. Have 2 minutes of time and try this question. Try this question. Let's see this. The question is saying a town is required to treat 4.5 meter cube per minute of raw water. Just 1 second. A town is required to treat 4.5 meter cube per minute of raw water for daily domestic supply. Flocculating particles are to be produced by chemical coagulation. The column analysis indicated that the overflow rate of 0.2 mm per second will produce the satisfactory particle removal in the settling basin at a depth of 3.2 meter. Okay. The required surface area is, so directly you are given with the surface overflow rate. Surface overflow rate is how much? Surface overflow rate is given as 0.2 mm per second. Okay. Discharge is also given as 4.5 meter cube per minute. So discharge is 4.5 meter cube per minute. Units are very important, right? Units are very important. So the first thing what you need to calculate is You can calculate the surface area direct using the surface overflow rate and the discharge. So surface area is equal to discharge divided by the surface overflow rate. Discharge is given as 4.5 meter cube per minute. This is 4.5 meter cube per minute. So better you convert this minute into seconds. So meter cube per second. This is now meter cube per second divided by the surface overflow rate, which is 0.2 into 10 raised power minus 3. Now this will be meter per second. This will be meter cube per second and this will be meter per second. So we'll get the surface area in meter square. Please tell me this answer. 375. This is 375. Yes or no? Let me also calculate this. So this is 4.5 into 1000 divided by 60 divided by 0.2. So this is 375 meter square. This is 375 meter square directly. Very good, Nikhil. Correct answer. Okay. So this is again one of the variety. Next, move ahead. Okay. Now next thing is coagulation and flocculation. Now my dear students, sedimentation is the process of removal of suspended solids. But if fine suspended solids are present in your water sample, these fine suspended solids require huge amount of time to get settled. Now what we do is, whenever more quantity of fine suspended solids are present in our water sample, we add a chemical and we just agglomerate these fine suspended solids together. And this process of agglomeration of fine suspended solids is known as coagulation and flocculation. Coagulation is fast mixing and flocculation is slow mixing, where we form the flocks. So coagulation and flocculation is done to agglomerate the fine suspended solid particles which are further settled in the sedimentation tank. So whenever fine suspended solids are present more in your raw water, then first we go with coagulation and flocculation and then we take up the process of sedimentation. Okay. Next is coagulation is fast mixing, which neutralizes the negative protective charge present over the surface of the suspended solids. The coagulants used are alum. First of all these coagulants, alum, copperas and chlorinated copperas, all these three coagulants, alum, copperas and chlorinated copperas, all these three coagulants will react with the alkalinity present in your water sample to form the sticky precipitate. It reacts with the alkalinity present in your water sample, to form the sticky precipitate, right? This is your sticky precipitate for these coagulants. Now these sticky precipitate is allowed to roam inside the volume of the sedimentation tank or the flocculation tank, right? Not sedimentation tank, flocculation tank. This sticky precipitate which is formed in the coagulation is allowed to roam inside the flocculation tank, so that small size of particle of fine suspended solids sticks over the surface of the sticky precipitate and forms a larger size of particle. And this sticking of the fine suspended particles over the surface of the sticky precipitate is known as agglomeration of the fine suspended solids, right? Now these three coagulants first of all reacts with the alkalinity present in the water to form the sticky precipitate. Next, if you are using the alum, it increases the acidity and the permanent hardness. The working range is 6.5 to 8.5, the pH. If you are using copperas imparts color and increases the permanent hardness of your water sample. The working range of copperas is above 8.5. Next, if you are using chlorinated copperas, it imparts color and it also increases the permanent hardness of your water sample. The working range is huge, 3.5 to 7 and above 8.5. Last, you have sodium aluminate. This is one of the most costliest coagulant, right? So that's why this is not used to treat the community water. This sodium aluminate is used to treat the boiler feed water. Sodium aluminate reacts with the hardness present in the water to form the sticky precipitate, right? And we know that whatever water we are supplying to the boilers, we do not want any hardness present in them. So basically, This sodium aluminate is used for either industrial purpose or it can be used to treat the water, which is a boiler feed water. Sodium aluminate is the only coagulant which reacts with the hardness to form the sticky precipitate. It reduces the hardness of the water. The working range is 6 to 8.5. Everything is important. Whatever thing is mentioned in the slide, everything is important. Chalo, next. So 1 gram of alum, this directly you can have a note. 1 gram of alum reacts with 0.45 gram of alkalinity as CaCO3 to form 0.234 grams of sticky precipitate. Now this statement is highly useful if you get a question from calculation of sludge, right? Next, alum is used for the treatment of water supplies, whereas RN salts, that is copperous and chlorinated copperous, are used for the treatment of sewage. Next you have the sodium aluminate is used for the treatment of boiler feed water. I have already told you this. Next you have the temporal mean velocity gradient. This temporal mean velocity gradient tells us about the intensity of mixing, right? So this temporal mean velocity gradient G tells us about the intensity of mixing. This tells us about the intensity of mixing. Intensity of mixing. If intensity of mixing is more, the value of G will be more. The value of G can be calculated as under root of P upon mu into V. Here this P is the power provided to the shaft. Mu is the dynamic viscosity of water. Second one, V is the volume of the tank. You can very well relate in your mind if you provide constant amount of power to two different shafts, right? First shaft is there in water. Okay, I'll write like this. For example, these are two tanks in front of you. This is my tank 1 and this is my tank 2. Okay, and in these tanks there are shafts provided like this. This is the shaft provided. This is one shaft and this is another shaft. Okay, both the shafts has to rotate like this. Both the shaft has to rotate like this. Everything is identical. Everything is identical about these two tanks. Volume, okay, power here is P1 and power here is P2, such that P1 is more than P2. Okay, observe this very carefully. Everything is identical about the tank. Volume of the tank, size of the shaft, everything is same. Volume of the tank, size of the shaft and dynamic viscosity of water, everything is same. Size of the shaft and dynamic viscosity, everything is same. Now you can clearly observe that in whichever tank power will be more, intensity of mixing will be more. So if intensity of mixing is more, it means the value of temporal mean velocity gradient will be more. So if every other thing is constant, more the power, more will be the value of G, temporal mean velocity gradient, right? Similarly, if I talk about G, so G is under root of P divided by mu into V, right? So G is directly proportional to power. G is inversely proportional to the dynamic viscosity. It is inversely proportional to the dynamic viscosity and G is inversely proportional to the volume of the tank. This is very, very simple. If dynamic viscosity is more, then the intensity of mixing will be less. If volume is more, again the intensity of mixing will be less. You have to take care that same amount of power is supplied. Okay, chalo next. Flocculation is termed as slow mixing. It is the agglomeration of the neutralized fine suspended solids. For large dense flocks, the value of G at the inlet is kept twice at G at the outlet. So as you move ahead in the flocculation tank, the value of G keeps on reducing. Okay, chalo, with this basics, just try this question. Try this question, get the answer. I'll again give you a timer for 2 minutes. Go for it. Keep commenting your answer in the comment box. Keep commenting your answer in the comment box. Do it. So let's see this question. Question says that the flocculation tank contains 2000 meter cube of water which is mixed using the pedals at an average velocity gradient of 100 per second. So I'll write down first of all volume of the tank is given as 2000 meter cube. This is 2000 meter cube. Next, okay, with an average velocity gradient, the value of G is 100 per second. Okay, next, the water temperature and the corresponding dynamic viscosity at 30 degrees Celsius mu is given to you as 0.798 into 10 raised power minus 3 Newton second per meter square respectively. The theoretical power required to achieve the stated value of G is, okay. So you need to directly use the value or the formula for G to calculate the power. So what is the formula for G? G is equal to under root of power divided by mu into V, okay. Now this can be written as power P is equal to G square into mu into V, right. You can use this expression to get the value of power. Use this expression to get the value of power, right. So power will be, substitute the value. So the value of G is 100 per second. So this is 100 square into mu. Mu is 0.798 into 10 raised power minus 3 multiplied by volume, which is 2000 meter cube per 2000 meter cube. From here the value of power you will get in watts. Just do the calculation. So this is how much? 0.798 into 2. So this will be 15960 watts. This will be 15960 watts. You need to report in kilowatts. So this will be 15.96 kilowatts. This is my final answer. So don't miss these questions, right? These are those variety of questions that should never be missed. All these are GATE previous year questions. I have just altered the data for some of the questions. Chalo, let's move ahead. Next, try this question. This is again a very good question. Go for it. I'll give you 2 minutes of time. Just do it. Do it. It's a very good question. 15.96. Very good, Nikhil. Very good, very good. Try this one also. Try this question as well. Again a GATE previous year question. Try this, try this. Answer for this, please answer this. Okay, the question says that the surface water treatment plant operates round the clock with a flow rate of 40 meter cube per minute. So discharge Q is given as 40 meter cube per minute. This is 40 meter cube per minute. The water temperature is 15 degrees Celsius and the jar test indicates that alum dose of 30 milligram per liter for producing optimum result. So alum dose required is 30 milligram per liter to produce the optimum results, right? The question is asking how much alum is required for 30 days in kgs. For treating 1 liter of water, 30 milligram per liter of alum is required. For treating total water in 30 days, how much alum is required? Okay, this is the discharge given to you. This is the discharge in 1 minute. Okay, so alum required for 30 days is alum required in 30 days is equal to, first of all, for 1 liter 30 milligram is required. For 1 liter 30 milligram, I write everything, right? I will write every unit. 30 milligram of alum is required in 1 liter. What is the discharge? 40 meter cube per minute. So this is 40 into 10 raised power 3 meter cube, sorry, this is 40 into 10 raised power 3 liter per minute, right? So this is the alum required in milligram per minute. Okay, I need to calculate it for 30 days. So 1 minute contains how many days? 1 minute contains, this is equal to 24 into 60. 60 minutes in 1 hour, and 1 day has 24 hours and total number of days is 30. So this is your alum dose in milligram required in 30 days. Now you need the answer in kgs, so you need to divide this by 1000. You need to divide everything by 1000. So now your answer will come out in kgs. So this is your alum dose required in 30 days and the answer will be in kgs. So this is 30 into 40 into 10 raised to power 3. So this is 2 will going to cancel out. 24 into 60 into 30. Just go for it. Do the calculation. So 30 into 40 is 1200. 1200 into 24. 1200 into 24 into 60 into 30. So this will be 5184. This will be 5184 0000 kgs. So I think the more appropriate answer will be in liters. Okay. So this is your final answer. Just check for any calculation mistake. I don't think there is any calculation mistake, but in case if there is any, just you can check for it, right? So this was again a simple question. This extra data is given to just to confuse you. Chalo, moving ahead. Next you have the filtration. Now my dear student, filtration is used for the removal of again fine suspended solids. Filters are of two types, gravity filters and you have pressure filters. Gravity filters are those filters in which the amount of energy required by the water to pass through the filter medium is provided by the head of water above the filter medium. Pressure filters are those filters in which the amount of energy required by the water to pass through the filter medium is supplied artificially in the form of artificial pressure. Okay. So filtration is of two types, gravity filters and pressure filters. Gravity filters are again of two types, slow sand filter and you have the rapid sand filter. Slow sand filter has more efficiency but less rate of removal. Reason is, in slow sand filter, the particle size is comparatively smaller as compared to the rapid sand filter. If particle size is smaller, then the size of voids is also smaller, which can clog or restrict more amount of fine suspended solids. That's why for slow sand filter you get more efficiency of treatment. Second, if the size of particle is small, then the specific surface area of the sand medium will be more. If a specific surface area is more, then the friction applied by the filter medium over the flowing water will be more. Hence, slow sand filter treats less amount of water in one day. So, rate of removal for the slow sand filter will be less as compared to your rapid sand filter. So, for rapid sand filter you have less efficiency but more rate of removal. For slow sand filter you have more efficiency but less rate of removal. And why this is? Because for slow sand filter the relative or the size of the particle is relatively small. Size of filter medium is particle. Size of filter medium particle is small as compared to your rapid sand filter. Okay. So for slow sand filter the size of filter medium is small, hence the efficiency is more but rate of removal is less. For slow sand filter all the impurities are restricted in the top layer. That's why for cleaning the slow sand filter you remove the top layer of the soil of the filter medium. But for rapid sand filter your impurities infilters throughout the filter medium. Hence just by removing the top layer will not clean the filter medium. For slow sand filter, for cleaning of slow sand filter we go for the mechanism of backwashing. Okay. So slow sand filters are cleaned by the mechanism of backwashing. Okay, moving ahead. For rapid sand filter, once again, slow sand filter are cleaned by removing the top layer of filter medium. Rapid sand filter is cleaned by the mechanism of backwashing. Next, for rapid sand filter, head loss through the expanded bed is same as head loss through the unexpanded bed. During backwashing, the bed will going to expand. So head loss through the unexpanded bed is same as the head loss through the expanded bed. Reason is, even if the bed is expanding, the specific surface area of the filter medium is not changing. The particles are same, the particles are not increasing or decreasing, right? Size of the particle is not getting changed. Size of the particle is same, hence specific surface area of filter medium particle is same. Hence the friction applied by the filter medium particle over the flowing water will be same. Hence the head loss through the unexpanded bed is equal to the head loss through the expanded bed. Next you have head loss through the filter medium is equal to HL is equal to D. D is the depth of the filter medium. 1 minus N, N is the porosity of the filter medium into G minus 1, right? Now this expression can be written for expanded bed as well as for unexpanded bed. So I will write down head loss through expanded bed is equal to head loss through unexpanded bed. Head loss through unexpanded bed. Head loss through expanded bed is equal to expanded size of filter medium into 1 minus porosity of expanded bed into G minus 1. So specific gravity is constant. For unexpanded bed, D is the size of the filter medium, then 1 minus porosity of unexpanded bed into G minus 1. Again a very important equation, right? Do not leave this equation. Sir, I get the answer as 51840. Okay, very good. Your answer may be correct, right? I think I made some mistake there. No problem. So for any type of filter, the surface area is equal to design discharge divided by the rate of filtration. Next you have porosity of the expanded bed is equal to backwash velocity by settling velocity raised to the power 0.22. Porosity of expanded bed is equal to VB by VS raised to the power 0.22. Here VB is the backwash velocity and Vs is the settling velocity of the medium particles, filter medium particles. Vs is the settling velocity of the filter medium particle. Chalo. Next, try this question. Try this question. Try this question. Go for it. Try this question. Do this question. Let's solve this. Now my dear students, in your GATE examination you will get so many questions like this, and most of the students get confused by seeing these type of questions of environment. Okay, every time the statements or the terms that will be used to frame the question, you may not be friendly with all those terms, but when you get a term from which you are not that much friendly, how to deal with those terms? Observe the unit. Okay, the one thing I will tell you is observe the unit and try to get something from the unit. Okay, this is one such type of question. Question says that a city is going to install rapid sand filter after the sedimentation tanks. Use the following data. Some data is given to you. Calculate the total surface area required for rapid sand filter and the number of filter units required. Okay, most of these questions are aptitude question, I'll tell you. Even the GATE examination is named as Graduate Aptitude Test in Engineering. So these questions are more aptitude based question. Now let's assume that you don't know anything about this question. Okay, now first thing is given to you, design loading rate of the filter is 300 meter cube per meter square per day. Just by observing the unit, I can understand that this term has something to do with the volume flowing per meter square area of the filter in one day. Just by observing this unit, I can say that this term has something to do with the amount of water getting filtered by 1 meter square area in one day, right? So this tells us about amount of water getting filtered by 1 meter square of the filter area. Second, you have design flow rate. Design flow rate means in 1 second how much water is flowing through the cross section. So using these two, this is how much amount of water is treated by 1 meter square of filter area, and this is the total amount of water flowing through the filter area in one day. Can I calculate the surface? Can I calculate the surface area of the filter medium? So surface area of filter medium is surface area of filter medium is discharge, which is 0.6 meter cube. This is 0.6 meter cube per second divided by the design loading rate of the filter, means through 1 meter square of filter area how much water is getting treated. This is the total amount of water getting treated, right? This is the total amount of water getting treated, divided by the water getting treated by 1 meter square of area. So this is 300 meter cube per meter square per day, right? This will going to give me the total area of the filter medium, but first you need to convert this seconds into days. The first thing is you need to convert this seconds into days. Convert this seconds into days. Okay, for converting this second into days, so into 3600 into 24. Now this will going to give me the area. Now this will be meter cube per day, and this is meter cube per meter square per day. So the answer will be come out in meter square. Your surface area will come out in meter square. Just do the calculation and get the answer. Just do this calculation and get the answer for me. So this is 0.6 into 3600 into 24 divided by 300. So 172.8 meter square. 172.8 meter square. This is the total area of filter medium. Now you know the surface area of one filter box, which is 50 meter square. So number of filter units required are, number of filter units required are, number of filter units, number of filter units required are, number of filter units required are total surface area of the filter medium, which is 172.8 divided by area of one filter box, which is 50. So how much this is? 172.8 divided by 50. So this comes out as 3.456. So you will always report the answer on the higher side. You will always report the answer for this in the higher side. You cannot provide 3.456 unit. Either you can provide 3 unit or 4 unit. 3 unit are not sufficient to treat complete water. So you will going to provide 4 unit. So your final answer will be your 4 units, right? So this is how you need to deal with these simple variety of questions. Chalo, move ahead. Moving ahead, let's see this question. Try this one. Try this question. Have a timer for 2 minutes. Go for it. Do it. It's a very good question. It's a very good question. Just do it. Let's see this. The question says that 0.9 meter deep bed of sand filter, length 5 meter and width is 3 meter. Okay. Just one. Okay, now am I audible, right? So the question is saying 0.9 meter deep bed of sand filter, length 5 meter, width 3 meter, is made of uniform particles. Diameter is 0.3 mm, specific gravity is 2.65 with bed porosity of 0.38. First of all, I have an unexpanded bed. I'll write it in the next slide, right? I'll explain you this properly. Observe this. This is my filter bed. This is my filter bed. The size of the filter bed or the depth of the filter bed, this is given to me as how much? This D, this is D. So size of the filter bed D is given to me as 0.9 meters, right? The porosity of this bed eta is given to me as 0.38. This is 0.38. Now what you did is, for this filter bed you have done the backwashing. So while doing the backwashing, the filter will going to expand. Now this is your expanded bed. This is your expanded bed, right? This is your expanded bed. One second. This is your expanded bed. The size for this, depth for this expanded bed is D dash. The porosity of this expanded bed is N dash, which is equal to VB by VS raised to the power 0.22. Okay. We are directly not given the value of this porosity, but in the question they have mentioned the value of backwash velocity and the settling velocity of the filter medium particle. Let's see this. You have, during the backwashing, the terminal settling velocity of the sand particle is 0.05 meter, and this is the rate of backwashing. The bed has to be backwashed at a flow rate of 3.6 meter cube per minute. Even for backwashing, they have given the discharge. They have not given the backwash velocity. So backwash discharge is given to you, and you know the area of the filter bed, which is 5 meter by 3 meter. So I'll write like this: backwash velocity, backwash discharge is given to you as how much? 3.6 meter cube per minute. This is 3.6 meter cube per minute. And your plan area is, how much? Plan area is length into width, which is 5 into 3 meters. 5 into 3 meters square, right? Now using this backwash discharge and plan area, you can calculate the backwash velocity. Okay. You can calculate this backwash velocity. So backwash velocity VB is equal to backwash discharge divided by your plan area. Backwash discharge divided by your plan area. So backwash discharge is 3.6 meter cube per minute. This is 3.6 meter cube per minute. And plan area is 5 into 3 meter square. So this is 15. So using this, you can get the backwash velocity. Just do the calculation. So this will be 3.6 by 15 divided by 15. 0.24 meter per minute. So this is 0.24 meter per minute. This is your backwash velocity. You also know the value of your settling velocity of the particle, which is given to you as 0.05 meter per second. So Vs is 0.05 meter per second. Now using this backwash velocity and settling velocity, first you calculate the porosity of the expanded bed. So porosity of expanded bed is equal to Vb by Vs raised to the power 0.22. So porosity N dash is equal to Vb. Vb is how much? Vb is 0.24 meter per minute. So this is 0.24 meter per minute. Convert this into meter per second. So divide by 60. So that will be meter per second into Vs, which is 0.05. So 0.05 whole raised to power 0.22. Okay, just do this and calculate the porosity of the expanded bed. So 0.24 divided by 60 into 0.05 raised to the power 0.22. So this will be 0.574. Porosity of expanded bed is 0.574. This is your porosity of expanded bed. Now one thing we know that head loss through the expanded bed is equal to the head loss through the unexpanded bed. Head loss through unexpanded bed is equal to head loss through expanded bed. Is equal to head loss through expanded bed, right? Now we have already seen the expression. I have already told you the expression for this. Head loss through unexpanded bed is equal to D into 1 minus porosity of unexpanded bed into G minus 1. So this is your head loss through unexpanded bed. Then porosity through expanded bed is equal to D dash into 1 minus porosity through expanded bed into G minus 1. Okay. D dash is what I want to calculate. You can just cancel out this G minus 1 and G minus 1, substitute all the values and get the value of D dash. D is given to you as how much? This is 0.9. So this is equal to 0.9 into 1 minus porosity of unexpanded bed, which is 0.38. This is 0.38 is equal to D dash. I need to calculate porosity of expanded bed is 0.574. So 1 minus 0.574. You can calculate this to get the value of size of expanded bed. Do it. So this is 1 minus 0.38 into 0.9 divided by 1 minus 0.574. So this will come out as 1.31. So D dash will come out as 1.31 meters. So this is the size of your depth of your expanded bed. This is the depth of your expanded bed, right? Again, a very important question can be asked for 2 marks in your gate examination. Okay, I hope chalo you have understood this. Let's move ahead. Chalo, next you have the disinfection. So disinfection is a process of killing all the disease causing microorganisms present in your raw water, right? There is difference between disinfection and sterilization. Sterilization is the killing of all the microorganisms, whether they are disease causing or non-disease causing. But disinfection is the mechanism of killing of only disease causing microorganism. Disinfection can be done through ozone, using KMNO4 and using chlorination, right? If you are doing disinfection using ozone, then what does ozone does is, ozone destroys the cell wall of the microorganism, leading to the killing of microorganism. KMNO4 increases the permeability of the pores of the cell wall. And if the permeability of the pores of the cell wall increases, whatever is the fluid present inside the cell, it flows out and leads to the killing of microorganisms, right? On the other hand, the chlorine destroys the necessary enzymes which are required for the existence of the microorganism, and hence leads to the killing of these microorganisms. So disinfection can be done either using ozone, it can be done using potassium permanganate KMnO4, or it can be done using chlorination. Chlorine destroys the enzymes responsible for the metabolism of microorganisms, ozone destroys the cell wall, and KMnO4 increases the permeability of the cell wall. Okay. Now, when you are doing chlorination when you are doing disinfection through chlorination and you are adding chlorine, as soon as you add chlorine, chlorine dissociates into HOCl, and this HOCl also dissociates into OCl minus ion. These are known as free available forms of chlorine. All these three forms of chlorine are capable to carry out the disinfection, but in the freely available forms of chlorine, HOCl is the most destructive disinfectant. At the same time, when you add chlorine to the water, chlorine also reacts with the ammonia present in the water to form chloramines. These chloramines are NH2Cl, NHCl2 and NCl3. These are chloramines, and these chloramines are known as the combined forms of chlorine. These chloramines are less destructive than the freely available forms of chlorine. So when you add chlorine in the water, chlorine will be present in the 6 different forms to carry out the disinfection. Out of these 6 different forms, HOCl is the most destructive form of disinfection of chlorine. HOCl will going to carry out the most of the disinfection, right? Chloramines are less destructive than freely available chlorine. This chlorine will exist when the pH of the water sample is less than 5. HOCl will exist when the pH of the water is between 5 to 7. This HOCl and OCl minus ion equilibrium will exist when the pH is between 7 to 8. And if the pH of the water is above 8, only OCl minus ion will exist. So whenever we are carrying out the chlorination, we make sure that the pH of the water sample is kept in the range of 5 to 7, where the dominance of HOCl is there. And if HOCl will be present, it will quickly carry out the disinfection of the water, right? Next, the number of microorganisms killed or left in the system after time t of disinfection is governed by the Chick's law. Chick's law says that number of microorganisms left in the system after time t is equal to n naught into e raised to the power minus k into t, where n naught is the initial number of microorganisms present in the system and nt is the number of microorganisms present in the system after time t. What is this time t? After time t of carrying out the disinfection. Okay. Next, try this question. It's a very good question. Go for it. Try this question. I'll give you just 2 minutes of time. Go for it. So let's see this. The question says that the wastewater is to be disinfected with 36 milligram per liter of chlorine to obtain 99% kill of microorganism. So efficiency of disinfection is 99%. Okay. The wastewater flow rate is 40 meter cube per hour and K is 0.23 per minute. If the depth and width of the chlorination tank are 1.5 meter and 1 meter respectively, then what is the length of the tank in meter, right? You need to find out the length of the tank. For that length, you are given with the depth and width of the tank. So depth of the tank is how much? 1.5 meter. Depth of the tank is 1.5 meter and width of the tank is 1 meter. So if you can calculate the volume of the tank anyhow, you can get the length of the tank as well, right? Now once again, a wastewater is to be disinfected with 36 milligram per liter of chlorine to obtain 99% of the kill of the microorganism. Observe this term, 99% kill. 99% kill, right? So if initially N0 were the number of microorganisms present, once the disinfection is started, in time t, the number of microorganisms which are left in the system is only 1% of N0. Okay. Now this is the time that we want to provide to carry out the disinfection. So this time is known as the detention time. So if I can calculate this detention time, multiplying this detention time with the discharge, I can calculate the volume. So my question reduces to calculation of this detention time. Now how to calculate this? This is the time in which 99% of the microorganisms are getting killed. So whenever the killing of microorganisms comes into play, I will use the Chick's law. So Chick's law says that NT, number of microorganisms left after time t, is equals to N0 into e raised power minus k into t, right? NT is nothing but 0.01 of N0, 1% of N0. NT is 0.01 of N0 is equal to N0 into e raised power minus k. K is given as 0.23. 23 into t. Now observe this. Here k is 0.23 per minute. So this time will also come out in minutes, right? So this N0 and N0 will going to cancel out. Just solve this to get the detention time t. This will be natural log of 0.01 divided by 0.23. So this will be 20.02 minutes. This time will be 20.02 minutes. This time will be 20.02 minutes. Now you observe this. So TD is 20.02 minutes. This is the time in which 99% of disinfection will happen. 99% of disinfection will be happening. So this is also the detention time. So volume of the tank is equal to discharge multiplied by the detention time. So volume is equal to, discharge is how much? Discharge is given to us as 40 meter cube per hour. Please take care of the unit. This is 40 meter cube per hour. meter cube per hour multiplied by 20.02 minutes. So 20.02, you need to convert this also into hours. So divide by 60. So this will be the volume of your tank. Just calculate this. So this will be 40 by 60 into 20. 13.347. Volume of the tank will be 13.347 meter cube. This is the volume of the tank. Now you know the volume of the tank, you know the depth, you know the width, you can calculate the length. So volume is equal to B into D into L. So volume is equal to 13.347. Width is 1 meter, depth is 1.5 meter. So 1 into 1.5 multiplied by the length of the tank. Calculate this. So 13.347 divided by 1.5. So 8.898 meters. 898 meters. This is the length of your tank. Okay. So indirectly they will going to provide you the details and you have to look into the things, right, what is given in the question, and accordingly you need to solve. Chalo, let's move ahead. Let's do this. Okay. So this finishes our first part, that is your raw water engineering. Now we will talk about your wastewater engineering. My dear students, if I just quickly brief you about wastewater engineering contains organic impurities as the major impurities. Organic matter of two types, biodegradable organic matter and the non-biodegradable organic matter. The amount of oxygen required only to decompose biodegradable organic matter is termed as biochemical oxygen demand, or BOD, right? What is BOD? The total amount of oxygen which is required to decompose only and only biodegradable organic matter is known as BOD. Second, the total amount of oxygen required to decompose biodegradable plus non-biodegradable organic matter is termed as chemical oxygen demand, or COD. So obviously your BOD will always be less than your COD. Chalo, move ahead. So first thing is BOD 5 at 20 degrees Celsius is equals to initial DO minus final DO multiplied by the dilution factor. Your BOD consumed is equal to BOD ultimate into 1 minus e raised to power minus k into T, where k is known as the deoxygenation rate constant. Your BOD remaining is equal to BOD ultimate into e raised to power minus k into T. Now the same formula of BOD consumed and BOD remaining can also be treated as BOD consumed is BOD ultimate into 1 minus 10 raised to power minus kd into T. Wherever kd will be mentioned, you have to take base 10. Wherever k will be mentioned, you have to take base e, right? In fact, in the question, it will be clearly mentioned which base you need to take for using this formulas. Similarly, BOD remaining is equals to BOD ultimate into 10 raised to power minus kd into T. Next, you have kd at any temperature T is equal to kd 20 into 1.047 raised to the power T minus 20. So these are some of the formulas that will be used. Let's do this. First question says that which of the following statement is correct? My dear student, first of all, if I talk about organic matter, I have just told you, organic matter. Organic matter is of two types, biodegradable and non-biodegradable. Organic matter is of two types, biodegradable and non-biodegradable. The amount of oxygen required to decompose only the biodegradable organic matter is known as BOD, or biochemical oxygen demand. Next, the total amount of oxygen required to decompose biodegradable plus non-biodegradable organic matter is known as COD. The total amount of oxygen required to decompose biodegradable plus non-biodegradable organic matter is termed as COD. Now clearly from this statement, I can write down BOD will be always less than COD. or there can be an equality. BOD will be always less than or equal to COD. If in the medium only biodegradable organic matter is present, in that case BOD will be equal to COD, right? So this is the condition. So first condition says that, okay. Now one thing is, this is your BOD ultimate, okay. What is BOD ultimate? BOD ultimate is the total amount of organic matter, total amount of organic matter present in the system. The total amount of organic matter present in the system, right? You understand it like this. BOD is the amount of oxygen required to decompose the organic matter. But the best way to understand BOD is you directly relate it with the organic matter. Just remove this oxygen from between. BOD is defined as the amount of oxygen required to decompose the organic matter, means more the organic matter, more will be the oxygen required, more will be the value of BOD. So just remove this oxygen. More BOD, more organic matter. More BOD, more organic matter, less BOD, less organic matter, right? So BOD ultimate is the total amount of oxygen required to decompose the organic matter. Now BOD 5 is amount of organic matter which decomposed in 5 days. So obviously BOD 5 will be always less than BOD ultimate. BOD 5 will be always less than BOD ultimate, okay. Now take care, now take this thing, BOD 5 will be always less than BOD ultimate. So if BOD ultimate is less than COD, then obviously your BOD 5 will be less than COD. So your statement A is your correct statement. BOD 5 will be always less than your COD. Next, BOD 5 is equal to COD? No. BOD ultimate can be equal to COD, but BOD 5 can never be equal to COD. Next, BOD 5 is greater than COD? No. BOD 5 is not equal to COD. This is absolutely correct. BOD 5 can never be equal to COD, right? So this is one of the questions. So for this question, statement A and D is your correct statement. Next, try this. Try this question. The question says that the following observations were made on 8% dilution of wastewater. Now, this 8% dilution is given to calculate the dilution ratio, right? Now, how to deal with this 8% dilution? This is just, I am giving you a trick to calculate the dilution ratio using 8% dilution, right? Means if any percentage of dilution is given to you, how to calculate the dilution ratio using that? How to calculate the dilution ratio if percentage dilution is given to you? So this 8% dilution, you can imagine it like this. 8% dilution means 8 ml of wastewater, 8 ml of wastewater is mixed with 92 ml of aerated water, to give 100 ml of diluted sample. To give 100 ml of diluted sample. This is just to make your calculation easy, just to make you understand, not to get confused by this percentage dilution, right? If any percentage dilution is given, you can just write down one statement like this. Make sure that the total is 100, okay? 8 ml of wastewater is mixed with 92 ml of aerated water to get the 100 ml of the diluted sample. Now from this, I need to calculate the dilution ratio. So what is dilution ratio? Dilution ratio is defined as the total volume of the diluted sample. What is the total volume of diluted sample? 100 ml. Dilution ratio is total volume of the diluted sample divided by the volume of original sample present in the diluted sample. So the volume of original sample is 8 ml, which is present in 100 ml of diluted sample. So I'll divide by 8. So just calculate what is this value. So this will be 12.5. So this is my dilution ratio. 12.5 is my dilution ratio, right? Now, dilution ratio I have calculated. Initial DO is given as 4.25 milligram per liter. DO of diluted sample after 5 days is given as 1.2 milligram per liter. What is the BOD5 at 20 degrees Celsius? So just do this. So DO initial is given as 4.25 milligram per liter. This is 4.25 milligram per liter. DO final is given as how much? DO final is 1.2 milligram per liter. This is 1.2 milligram per liter, right? Dilution ratio you have already calculated, which is 12.5. Okay. Now BOD5 at 20 degrees Celsius. BOD5 at 20 degrees Celsius is equal to DO initial minus DO final multiplied by the dilution ratio. This is your BOD5 at 20 degrees Celsius. So DO initial is 4.25. So this is 4.25 minus 1.2 into dilution ratio, which is 12.5. So directly you will get BOD5 at 20 degrees Celsius in milligram per liter. Do the calculation. Just do the calculation. This will be 4.25 minus 1.2 multiplied by 12.5. So this will be 38.125 milligram per liter. So BOD5 will be 38.125 milligram per liter. This is your BOD5 at 20 degrees Celsius. This is the value of your BOD5 at 20 degrees Celsius. Okay, chalo, moving ahead. Next question. Try this. I'll give you just 1 minute of time this time. Okay. Try this. Try this. Try this. Okay, now observe this. The question says that the following observations were made on 12% dilution of wastewater. Second, initial DO of diluted sample is 6.23 milligram per liter. The final DO of after 5 days of incubation is 0 milligram per liter. Sir, can't be determined. Very good, Khushbu, very good. So whenever your DO final is 0 milligram per liter, you will never report BOD5. What is the reason for that? Just observe this. This is your wastewater sample kept inside the incubator. Okay. This is your wastewater sample which is kept inside the incubator like this. Now, there could be a possibility that whatever is the dissolved oxygen present in this wastewater, whatever is the dissolved oxygen which is present in this wastewater, right? This dissolved oxygen would have been neutralized before 5 days. And if there would have been more dissolved oxygen, then there could be the possibility of more oxidation of the organic matter or decomposition of the organic matter. So whenever your final DO is 0, in that case you report BOD as BOD cannot be determined. BOD5 cannot be determined. Cannot be determined. Please remember this every time. BOD5 cannot be determined, right? Chalo. Next, try this question. Try this question. Try this one. I'll give you again 1 minute of time. Do it. 1 minute of time for you. Do it, do it. Do this question. So let's solve this. The question says that the following observations were made on 4% dilution of wastewater. First of all, for this 4% dilution of wastewater, I would write it like this. The 4% of dilution of wastewater, 4% dilution of wastewater, dilution of wastewater means that 4 ml of wastewater is mixed with 96 ml of aerated water to form 100 ml of diluted sample. This is just for understanding to calculate the dilution ratio, right? This is not the actual thing happening in the field or in the lab. This is just for your understanding to calculate the dilution ratio whenever percentage dilution is given to you. So from here, dilution ratio is equal to 100 final volume of the diluted sample or the total volume of the diluted sample divided by the volume of original sample present in the diluted sample. So the volume of original sample present in the diluted sample is 4. So dilution ratio is 25, right? Now next, DO of aerated water used for dilution is 5 milligram per liter. This time DO for aerated water is given to you. DO for aerated water is given to you as how much? This is 5 milligram per liter. DO for aerated water is 5 milligram per liter. Next, DO of original sample of wastewater is 0.8 milligram per liter. So DO for original sample of wastewater is, or DO for wastewater is 0.8 milligram per liter, right? Now this time in the question they haven't given the initial DO. Instead of giving the initial DO, they have given me the DO of wastewater and the DO of aerated water. So I need to calculate the initial DO of this diluted sample. Now observe this. The initial DO of diluted sample is equal to dissolved oxygen of wastewater into volume of wastewater, which is 4, plus dissolved oxygen of aerated water into volume of aerated water, which is 96, divided by the total volume, which is 4 plus 96. This is known as taking the weighted average of dissolved oxygen to calculate the initial DO of the diluted sample. This is DO initial for diluted sample. This is DO initial for diluted sample, right? Just do this. So DO of wastewater is 0.8, volume of wastewater is 4. It is mixed with aerated water having DO of 5 milligram per liter and volume is 96 ml divided by 4 plus 96. Just get me this value and tell me this value. Initial dissolved oxygen for your diluted sample. So this is 0.8 into 4 plus 5 into 96 divided by 100. So this will be 4.832. So So DO initial will be, DO initial of diluted sample is, DO initial of diluted sample is 4.832 milligram per liter. This is your DO initial for the diluted sample. You are given with the final DO of the diluted sample after 5 days of incubation, and that is 1.2 milligram per liter. So DO final is 1.2 milligram per liter. DO final is 1.2 milligram per liter. Okay. Now you know the value of DO initial, you know the value of DO final, you can calculate BOD5. So BOD5 is equal to DO initial minus DO final multiplied by the dilution ratio. So DO initial is 4.832 minus DO final, which is 1.2, into dilution ratio, which is how much? 25. Dilution ratio we have calculated as 25. Just calculate this and get me the value of BOD5. So this is 4.832 minus 1.2 into 25. So BOD5 comes out as 90.8. This is 90.8 milligram per liter. Now just check what we need to calculate. The question is asking us to calculate BOD5 or something else. Just check whether the question is asking us to calculate what. So the question is asking us to calculate the value of ultimate BOD, and here the value of KD is given to you as 0.1. So whenever KD is given, you need to use base 10, right? You need to calculate BOD, ultimate BOD. Now we will use this BOD5 to calculate the ultimate BOD. So I can write down this BOD5 as BOD5 is equal to BOD ultimate into 1 minus 10 raised power minus KD into 5. Time duration is 5 days. So KD into 5. Substitute the value of BOD5. So BOD5 is 90.8. This is equal to BOD ultimate into 1 minus 10 raised power minus 0.1 into 5. The value of KD is given as 0.5. You can solve this to get the value of BOD ultimate. Do this. So this is 10 raised power minus 0.5, 1 minus answer 90.8 divided by answer. So 132.8 or 792. BOD ultimate will be 132.792 milligram per liter. This is your BOD ultimate. Again, this was a 2-mark question, or you can expect this as a 2-mark question in your GATE 23. Especially those who will be appearing for environmental engineering as the separate paper. You can expect this variety of question. Okay, I hope this was clear to you. Let's move ahead. Let's move ahead. Take this question. I think this is the same question. Okay, let's check. Okay, try this one. Try this one. I have 2 minutes of time. Try this one. The question is saying BOD5 of a wastewater has been measured as 700 milligram per liter. If KD is equal to 0.1 per day base 10, what is the percentage of ultimate BOD would remain oxidized after 30 days? Okay, this is unoxidized basically, not oxidized. How much amount of BOD ultimate remains unoxidized after 30 days? Okay, so basically what they are asking us to calculate what is the BOD remaining after 30 days. Unoxidized organic matter means what is the remaining organic matter, and remaining organic matter means what is the BOD remaining. Now just see this. So first of all, I'll write like this: BOD5 is given as 700 milligram per liter. So first I need to calculate the ultimate BOD. So BOD5 is equal to BOD ultimate into 1 minus 10 raised power minus KD into 5. Okay. Substitute the value of KD, substitute the value of BOD5 to get the value of BOD ultimate. So BOD5 is 700, BOD ultimate into 1 minus 10 raised power minus KD is 0.1. So minus 0.1 into 5. Get the value of BOD ultimate from here. Just do the calculation. So this is 10 raised power minus 0.5. 1 minus answer. Okay, 700 divided by answer. So this will be 1023.732. BOD ultimate is 1023.732 milligram per liter. Right, this is your BOD ultimate. Now you got the BOD ultimate, you can calculate what is the BOD remaining after 30 days. BOD unoxidized, you can calculate this very well. You can calculate this very well, right? Let's do this. So you have BOD remaining after 30 days. This is equal to BOD ultimate into 10 raised power minus KD into 30. This is your BOD remaining after 30 days, right? Divyanshu is saying 1023. Very good, Divyanshu. That is your BOD ultimate. Now using this BOD ultimate, we will calculate BOD remaining. So BOD ultimate is 1023.732 into 10 raised power minus 0.1 into 30. So this will going to give me the value of BOD remaining. Okay, do this calculation 1023.732. Very good, Divyanshu. Just do the calculation for this into 10 raised power minus 0.1 into 3, so minus 3. So this will come out as 1.023 milligram per liter. So this will be your BOD remaining after 30 days. This is the amount of organic matter that will be remaining unoxidized after 30 days. This is the amount of organic matter that will be remaining unoxidized after 30 days, right? Okay. So this question is clear to everyone? Okay. Let's move to the next question. Try this one. Try this question. It's a very good question. It's a very good question. Try this. I'll give you just 1 minute of time. Very good, Divyanshu. Try this one also. It's a very good question. It will try to give you more concepts than half an hour of reading. Just try this. I'll give you 2 minutes of time. Go for it. Try this question. It's a very good question. So let's see this. The question says that a wastewater stream has a flow of 3 meter cube per second, ultimate BOD of 80 milligram per liter, is joining a small river having a flow of 11 meter cube per second, ultimate BOD of 4 milligram per liter. Both water streams get mixed instantaneously. Cross-sectional area of the river is 60 meters square. Assuming K is equal to 0.25 per day to the base E. The BOD in milligram of the river water 25 kilometer downstream of the mixing point is. Means the question is asking us to calculate what is the BOD remaining of the water 25 kilometers downstream. Okay, now observe this very carefully. This is your wastewater stream, right? This wastewater stream is getting mixed with the river stream. This wastewater stream is getting mixed with the river stream like this. This wastewater stream is getting mixed with the river stream to have the mix from this cross section. This is your sewage stream. This is your river stream. And here they are getting mixed instantaneously, right? So this is the cross section below which you have this mix, right? Below this cross section you have the mix. Okay. Now some parameters are given to us. First of all, for the sewage stream, the discharge is given as 3 meter cube per second. So I will write down Q for sewage stream is equal to 3 meter cube per second. Next, Q for river stream is how much? Q for river stream is 11 meter cube per second. Q for river stream is 11 meter cube per second. Okay, chalo. Next, ultimate BOD of river stream is 80 milligram per liter. So, BOD ultimate for sewage stream is 80 milligram per liter. The BOD ultimate for the river stream is 4 milligram per liter. BOD ultimate for river stream is 4 milligram per liter. Okay. Next, both the water streams get mixed instantaneously. The cross-sectional area of the river is given as 60 meters square. So, area of cross-section, the area is constant first of all throughout, and the area of cross-section of the river, area is given as 60 meters square. The area of cross-section of the river is given as 60 meters square. Now, next is what you need to do. You need to find out the BOD in milligram per liter of the river stream 25 kilometer downstream of the mixing point. Okay. You need to find out BOD. Okay. This is not the BOD remaining. This is the BOD consumed. How much BOD will be consumed? If nothing is mentioned in the question, it will be BOD consumed, not BOD remaining. You need to find out BOD in milligram per liter of the river water 25 kilometer downstream. Now observe this, how to solve this. First of all, if 3 meter cube of discharge is mixing with 11 meter cube of discharge, the discharge of the mix will be, okay, 1 second, the discharge of the mix will be, let me just shift this. First thing, Q for mix, discharge for mix is discharge for sewage stream plus discharge for river stream. Discharge for sewage stream is 3 and discharge for river stream is 11. So, Q for mix is 14 meter cube per second. This is the discharge for your mix. Okay, this is your discharge for your mix. Next, for calculating this BOD, right, after 25 kilometer, you need to know BOD ultimate of the mix. So, for calculating BOD ultimate of the mix, BOD ultimate of the mix is equal to BOD ultimate of sewage stream into discharge of sewage stream plus BOD ultimate of river into discharge of river divided by discharge of sewage stream plus discharge of river. Every time we are taking the weighted average for calculating any parameter of the mix, you need to take the weighted average with respect to the discharge, right? Just do this. So, BOD ultimate for sewage is given to us as 80. So, 80 into discharge of sewage is 3 plus BOD ultimate for river is 4 milligram per liter and discharge for river is 11 divided by discharge for sewage plus discharge for river. From here, get the value of BOD ultimate of the mix. So, this is 80 into 3 plus 44 divided by 14. So, 20.285 milligram per liter. So, BOD ultimate for the mix is 20.285 milligram per liter. This is your BOD ultimate of the mix. Now what you need to calculate? You need to calculate BOD consumed after 25 kilometers. So first thing what you need to do is, you need to calculate the time in which the river is flowing this 25 kilometer. You need to calculate the time in which this river is flowing this 25 kilometers, right? Now how I can calculate the time? If I know the velocity of flow, I can calculate the time in which the river is flowing this 25 kilometer. For calculating the velocity of flow, there is two data given to us. First one is, you know the cross-sectional area of the river. Second, you have calculated the discharge of the mix, right? So using cross-sectional area and discharge of the mix, you can calculate the velocity of flow of the mix. So I can write like this: discharge of mix is cross-sectional area multiplied by velocity of flow. So discharge of mix is 14 meter cube per second. This is 14 meter cube per second. Area is 60 meter square into velocity of flow. From here you will get the velocity of flow in meters per second. Just calculate this: 14 by 60. Calculate 14 by 60. So this will be 0.233 meter per second. Velocity of flow is 0.233 meter per second. This is your velocity of flow. Velocity of flow is 0.233. Very good. 20.57. Divyanshu is telling me which answer. 20.57. This BOD ultimate. Okay. Let's check. I got it as 20.285. You can check on this. So velocity of flow I have got. Now we'll calculate the time in which the water is flowing from this section 25 kilometers downstream. So time T is equal to distance upon velocity of flow, distance upon VF. Distance is 25 kilometers, so convert this into meters. So 25,000 divided by velocity of flow, which is 0.233. 0.233, right? So this will give me the time in which units? Observe this. It is in seconds. So this will give me the time in seconds. So time in seconds will be 0.2. This is equal to 25,000 divided by 0.233 seconds, right? Now one thing, this is the time in which the water will flow from section XX to 25 kilometer downstream. Now I need to calculate BOD consumed after this time. So BOD at any time t is equal to BOD ultimate into 1 minus, okay, I have to check in which unit the value of KD is given. So KD is given to the base E and this is in per day. So KD is to the base E. So E raised power minus KD into T. K is given and it is to the base E, right? Now next. Here the value of K in was given in per day. So the time I have to calculate in days. So for calculating the time in days, the seconds needs to convert into days. So time T is equal to 25,000 divided by 0.233 into 24 into 3600. Now this will come in days. This will be the time in days. Just do this. This will be 25,000 divided by 0.233 divided by 24 into 3600. So this will be 1.241 days. This will be 1.241 days. This is the value of T, 1.241 days, right? 42. If you round this off, this will be 1.242 days. Just substitute the value. So BOD after time t or BOD after 1.242 days is equal to BOD ultimate. BOD ultimate of mix, which is 20.285. So 20.285 into 1 minus e raised power minus k is 0.23 into time, which is 1.242 days. Whenever nothing is mentioned, every time you need to calculate BOD consumed. Okay. If you need to calculate BOD remaining, it will be clearly mentioned in the question. Now this is the BOD of the mix 25 kilometer downstream. Calculate this. So you have e raised power minus 0.23 into 1.242. 1 minus answer into 20.285. So this will be 5.04. BOD after 1.242 days is equal to 5.04 milligram per liter. So this is the BOD which is asked in the question. 5.04 milligram per liter, right? So we have covered so many things today, right? We have also covered the BOD part. Whatever we have discussed, all these PDFs are available in our Telegram group. The link is given in the description box. Just after the session, I'll post this in the Telegram group, right? So you can collect these PDFs in your Telegram, from that Telegram group. Again, I would like to remind you, my dear students, just few last announcements and then we will close this. So all these are there, all these details will be there in the PDF. You can also solve the remaining questions. Now, last thing is, we at IMS GATE Academy provide you with free YouTube lectures, and the schedule of these YouTube lectures you can take from the Telegram group. For daily quizzes, again you can enjoy the flavor of different questions in our Telegram group. For getting the regular updates, we post regular videos and job notifications in our Telegram group. And lastly, we at and the description for this Telegram group is there. Sorry, the link of this Telegram group is there in the description box. Lastly, we at IMS GATE Academy provide you with different types of courses. We provide you with online program, offline program, hybrid program, and the self-learning program, where we provide you with more than 800 hours of live teaching, along with doubt solving and interactive sessions. We provide you with 130 plus online tests, which include chapter test, subject test, advanced subject test, multiple subject test, and the full length mock test, which is one of the most important feedback system required in GATE preparation, right? Doesn't matter whichever concepts you have read, until unless you don't have a feedback through these tests, you cannot improve on that. So these tests are very important part. We provide you with 12 personalized one-to-one mentoring sessions. I already told you about this. We only at IMS GATE Academy personally take care of all our students, guide them regularly so that they can have an efficient week, to have an efficient month, to have an efficient preparation journey, right? Lastly, we provide you with 30 plus theory books and exercise book. Especially in our exercise book, the questions are placed like level 1, level 2 and level 3, so that even you can have the idea of what is your preparation level, right? So I hope tomorrow, yesterday and today, you have enjoyed so many concepts, you have revised so many things through the questions. I hope you have liked the sessions. Please share it with your friends. Let them also study with these sessions. These are very, very important questions. The remaining questions you will get in the form of PDF, so you can practice that as well. So this is all for my side. Thank you so much for listening patiently. You were such a beautiful audience. Thank you so much. I'll see you with another subject, another session. Thank you so much for this.